In this lesson we're gonna learn the basics of measuring transducers and sensors. We're gonna learn about some general characteristics and also about electrical converters, sensors, types of electrical sensors, natural sensors, thermoelectrical sensors, thermoresistant sensors from reference materials, thermosistors, thermal pairs, infrared sensors, thermal cameras, and the application of all the above. Measuring transducers are devices that turn one form of energy into another. There are different types of energy. For example, kinetic energy is a characteristic of a moving body. Potential energy of a body is an energy in a physical field. Mechanical energy is the sum of microscopic kinetic and potential energy. Mechanical wave energy is energy transmitted by the propagation of mechanical waves in a material, for example, acoustic energy. Chemical energy, the characteristic of represents the characteristic of chemical substances to release heat or change into other chemical substances. Then we have got electrical energy. This is the energy that comes from electrical field, and the last one is magnetic energy. That's energy that comes from magnetic field. Then we also have nuclear energy. That's energy which binds protons and neutrons to the nucleus of an atom. Energy of ionization. This is the energy which binds electron to the nucleus of an atom. Elastic energy is an energy of plastic metal deformation. Gravitational energy, which originates from the gravitational field of the Earth. Energy of a steel body. This is the energy owned by the resting mass. E equals m times c squared. Thermal energy, which is microscopic measure of medium kinetic energy of a molecule in a material, or the so-called measure of entropy. Heat energy is the amount of thermal energy transferred in the direction of the decreasing temperature gradient. And mechanical work energy, which is the amount of energy transferred due to a change of position in the direction of an action of a mechanical force. Electrical converters are divided into actuators, sensors, and indicators. Actuators convert electricity into mechanical work or vice versa. Sensors convert some form of energy, except mechanical, into electrical and enable its quantification. That is, they determine numerical values of physical quantity or measurement. And finally, indicators are electrical converters that only indicate the presence of some form of energy, but do not allow its quantification, or the error of that quantification is unacceptably large. Sensors are devices that change some of their properties, usually electrical or chemical, under the influence of a physical phenomenon. That is, its numerous values or changes in those numerous values. The sensor is characterized by a number of parameters, such as sensitivity, selectivity, range, resolution, offset, nonlinearity, noise, and reversibility. Types of electrical sensors. One of the basic divisions of sensor is passive and active. Sensors are divided according to the type of size that they convert into electricity into. So we've got electromechanical, electroacoustic, electro-optical, thermoelectric, tensile resistant, thermo-optical, radio-optical, and radiological. Natural sensors. Living organisms also have appropriate sensors that help them interact with the environment. They are usually made up of specialized cells sensitive to intensity and/or wavelength of electromagnetic radiation, strength and/or wavelength of acoustic waves, including ultrasound and infrasound, mechanical pressure and vibration, molecules from the environment, sense of taste, sense of smell, pheromone sense and hormonal sense, gravitational field, sense of balance, sense of orientation, ambient temperature, ambient humidity, magnetic field, electric field, internal state of individual organs, level of certain hormones, chemicals or signaling molecules, protein structure of one's own organism in relation to the protein structure of foreign bodies. Thermoelectrical sensors. These are a special group of sensors that enable the measurement of temperature electrically. Temperature is most often measured in biomedicine but also in industry. These include heat-resistant sensors made of reference materials, thermistors, thermocouples, thermography, infrared sensors, and thermal cameras. Thermoresistant sensors from reference materials. These are sensors made of reference materials, which have precisely determined values of resistance at specific temperature. Thermistors. Thermistor is a temperature-sensitive resistor made of semiconductor materials like germanium, chromium oxide, cobalt, iron, etc. The change in resistance with temperature is distinctly nonlinear. Thermopairs. They are made of wires comprised of various metals connected at one end. The end where the wires are connected is called warm end or measuring end. The other end of the wire is at reference temperature and it is called cold end. Thermopairs or thermocouples. In this figure you can see the reception and linearity of thermopairs of K-type. Thermography. It refers to principle of non-contact temperature measurement. According to Wien's law of displacement, a body that absorbs 100% of the radiation falling on it, or absolute black body, and which is in thermodynamic equilibrium, emits radiation whose maximum at the wavelength is inversely proportional to the thermodynamic temperature. The power of radiation detected from a real body is a combination of three powers. P measured equals P emitted plus P reflected plus P released. Infrared sensors. The whole range of temperature of interest for industrial measurement, which goes from minus 220 degrees Celsius to plus 1000 degrees Celsius, corresponds to the wavelengths of the infrared part of the spectrum, or the IR. A graphical representation of the dependence of the wavelength of the maximum radiation of the body surface temperature according to the Wien's law of displacement is given in the following figure. Thermal cameras. In order to obtain a thermal image of a certain space, it is necessary to combine a large number of infrared sensors and connect them into a rectangular matrix. Each sensor in the matrix defines one point, or one pixel, of a space in front of it. And these are the examples of different thermal cameras. Application or use. Thermographic devices are most often used to detect temperature profiles on the surface of objects that deviate from normal, by which possible problems are identified. Application is also widely present in industry, biomedicine, etc.